Welcome to example 2 in optics about prescribing lenses. In the previous lesson, we did an example of how we can correct some eye defects. Let's see this question number 2. Try cannot see clearly things which are further than 200 centimeters. Name the defect of his eye and prescribe the lens which is suitable. So we know that the answer is this, but let's see if that's true. The question says that cannot see things further than 200 centimeters. So meaning that beyond 200 centimeters, Try cannot see. So his far point is 200 centimeters. We learned that the far point for a normal eye should be infinity. So if it is not infinity, the person is short-sighted, cannot see clearly beyond 200 centimeters. So they say name the eye defect. The eye defect is myopia or short sight. Short sight. So again, they want us to prescribe a lens. We prescribe by knowing which type of a lens, either diverging or converging, and therefore we need to know the power of that lens. Power of a lens is 1 over the focal length in meters. According to the diagram, the far point of this person is 200 centimeters, meaning beyond this, the person cannot see clearly. So what we are striving to get is, we need to be able to get all objects that are at infinity to be focused at his far point, meaning that the image is going to be formed at his far point and for all objects which are at infinity. The object here is infinity, and the image here is 200 centimeters. Since the power is always required in meters, we shall change this to meters, which becomes 2 meters. And the image and object, so the object are all on the same side. Since we shall place our lens somewhere here, so the lens is going to be diverging. We shall prove that. The lens is placed here near the eye, about 22 centimeters usually. So the image and object are on the same side as the lens of the lens. Therefore, one of them would be negative or virtual. So this is going to be virtual. The image will be virtual, deformed. We have a formula which is lens equation, 1 over d object plus 1 over d image is equal to 1 over the focal length. 1 over d object is infinity plus 1 over d image, which is negative 2. This is going to give us negative 0.5 d. Since the answer is negative, we realize that it should be a diverging lens. Focal length of a diverging lens is negative, and also the power is now 0.5 d.